Okay, so going over the answers to blue 37 and 38, it's going to be very similar to the last one. I'll go through it as quickly as I can, but I want to be sure that I cover everything. So we've got a 15 kilogram box. It's on the floor. It's being pushed at constant velocity across the floor. So we've got 15 kilograms, F grav, F norm. We've got an F applied. We've got an F friction. We know that the force of gravity is equal to 15 times 10, and that's 150 newtons. We know that these are all zero because it's constant velocity. We don't know anything about this applied force, but we do know that they're going to be equal. So we know that F applied equals F friction because it's constant velocity. The next one, a 15 kilogram box moving across the floor with an acceleration of 10 meters per second. Friction force is 5 newtons. So we've got a 15 kilogram box, and because I'm trying to get this done as a little bit faster time, we already calculated up here the 15 kilogram was 150 newtons. I'm just copying that. We know that it's going to be balanced. We know that there's probably an applied. There's also going to be a friction force that they told us was 50. We know that it has an xward acceleration, 10 meters per second squared. The net force has to be to the right. So F net equals mass times acceleration. So we've got 15 kilograms times 10, which is equal to 150 newtons. So we've got 150 newtons. So to find F applied minus F friction equals 150, we know that the friction is equal to 50. So our F applied is equal to 200 newtons. The next one, we have a 5 kilogram book falling from the roof. We're neglecting air resistance. So we've got 5 kilograms. We've got gravity. We have nothing else. Since it's falling and there's only one force acting on it, we know that there's got to be some kind of net force. So F grav is going to be 5 kilograms times 10 meters per second squared, which is equal to 50 newtons. So we've got 50 newtons. We know our net force in the y direction is 50 newtons. We don't know what the acceleration is. So F equals m times a. So it's going to be 5 times 50. No, that's wrong. We have acceleration equals F net over m because we're trying to solve for F net. So A equals 50 newtons divided by 5 meters, 5 kilograms. So 5 kilograms. So it equals 10 meters per second squared. 10 meters per second squared down. Now we have a 20 kilogram box falling from a roof at constant velocity. So 20 kilograms, constant velocity. We've got F grav. Doesn't tell us to neglect air resistance, so we've probably got air resistance. And since it's going to be balanced forces, we know we're going to have something balancing off of gravity. So we've got 20 kilograms times 10 meters per second squared equals 200 newtons. So we've got 200 newtons here, and it's balanced, so it's 200 newtons upwards. Okay, number 5. we have a 100 Newton force is applied to a 20 kilogram box to move it across the floor with an acceleration of 5 meters per second squared. So we've got a 20 kilogram box. We've got an applied force of 100 newtons. We know we have gravity. We know we have to have normal. We can assume it's moving, so it's got friction. It's got an acceleration of 5 meters per second squared across the floor horizontally. Balanced forces in the y direction. F, gravity, we calculated for a 20 kilogram in the last one, so we can 200 newtons, and it's balanced. And here we need to solve for the net force. So F net equals mass times acceleration, which equals 20 times 5, which equals 100 newtons. So it's 100 newtons to the right. So F applied minus F friction equals 100 newtons. Applied is 100. Friction must be 0. There must not be any friction at this point. Number 6, 200 Newton frictional force opposing the motion of a 50 kilogram object. It's moving with an acceleration of 10 meters per second squared. So we've got a 50 kilogram object. There is a 200 Newton frictional force opposing the motion. It's moving with a 10 meters per second squared acceleration. So we have an F norm and an F gravity and an F norm. And it doesn't say there's an applied force, but I'm going to assume that there would be something keeping this moving. It could be like in the last problem where we solved for the friction and it ended up being 0, but I'm going to put it in there for right now just in case. So we have a 50 kilogram object, so the force of gravity is equal to 50 kilograms times 10 meters per second squared, which equals 500 newtons. And it's balanced in the y direction, so that's also 500 newtons. So then we have F net equals m times a. So we've got 50 kilograms times 10 meters per second squared. That equals 500 newtons. So I've also got a net force here of 500 newtons, and that's to the right. So to find F applied minus F friction, that equals our net force, that's 500. So F applied minus 200 equals 500. So our F applied here has to equal 700 newtons. Okay, and that is it, because these two problems have coefficient of frictions, and that is not something that we're currently covering in this class. All right, so ladies, you should go ahead and work on MOP apps NL7, NL8, and NL9. They take various parts of what we've been going over. Some of them you're going to find to be extremely easy. Others of them you might find to be a little bit more challenging than what we were doing here. But overall, you should be really well prepared to do them, and then you can go ahead and take the assessment.